Hello everybody and welcome to a new and interesting mini sub project. I was actually thinking on that memory device. The last movie before this one was about non-volatile and volatile memory, and I presented there my version, which is a do-it-yourself one, and I've totally completely forget to mention about flash memories, which are used in a ton of products today in microcontrollers, from microchip PIC microcontrollers and Atmel, and not to mention the stick, USB stick data storage that you insert it into your USB computer, and you store data on it, and that's also on flash technology. And I completely forget. Shame on me. Shame, very very shame on me. But I mentioned this mechanism and how to drive it with this motor. And to exemplify, I can show you how it's actually working. If I'm pressing this button, which is the bounced button here, is sending a signal, a clock signal to this 4027. So it's a very sharp signal that I'm sending it to this flip-flop. And I'm putting a very smart way of lighting these LEDs. As you can see, I am powering everything from 3 volts and not from 5 volts, because I'm powering with 3 volts, like that. These LEDs are white LEDs, and because they are white LEDs, they need a little bit more forward voltage to open up, which I'm always use them for tests of this here. And so they need minimum voltage is 2.5 when they are barely lit, but because their forward voltage is very close to 3 volts or around 3 volts, so me using that 3 volts originally, it's perfect. It's almost perfect for them to be driven without any kind of resistor, protection resistor. So that's why I used these two LEDs directly like that, without any protection resistor on them. I should probably put at least a few hundreds of ohms, I don't know, 200, 500, one single resistor here from the positive to these two altogether, because it's lighting only one is lighting up when the signal is switched here, in the final version, of course. But here, in this testing setup that I'm having here, it's quite smart. It was a smart decision to do it like this. I'm pretty sure I know what I'm doing, and for this voltage level, it's perfectly safe for the LEDs not to be burned. But in other tests, if I will increase the voltage, or the voltage will be unknown, then it's good to have a protection resistor there. So that's my point. The only reason I'm using this 3 volts that you are seeing there is only for the motor here, because if I'm putting 5 volts, I actually tested it with 5 volts, and it's starting to smell as heated copper wire. And I tested for a very brief time before I made the circuit, and then I decided, well, let me test with 3 volts and see if it's working. It was working with 4027 and 3 volts, so I'm happy with this with this voltage setup that I'm having here. So that's a good thing that is working for at 3 volts. So right now, if you can see here, is doing this was very tricky actually to make it this stopping element. Let me put it back. I have to press it with my tweezer, with my bigger tweezers. I have to press it down, and yeah, see, it's doing the job. It's doing the business. Let me actually zoom in. It's doing the flip-flopping exactly like you see, like my LEDs are showing here. And when I'm pressing the button, it's doing the flip-flopping. Of course, it's pushing back that stopping element there that is barely resisting, and it give up. So I'm back. Let me test it some more. As you can see, when I'm pressing here, it is flipping exactly like I explained from 0 to 1. So 0 to 1. Of course, I didn't put the reading element. What I'm having here is only the motor drive circuitry. And here is the circuit that I drew it after I built it here. And I didn't made this circuit. I didn't integrate it here, but I only noted it as a clock there. This is the programming of this 4027 chip, pin, which one is 4 and 7, and also the 8 to the ground, and pin 5 and 6 to plus 3 volts. I actually specifically put 3 volts everywhere to be aware. These LEDs, they don't have a resistor on them, and they are inversed. They should be to the ground here when the positive signal is coming from that first pin, going through that LED to the ground. It should have been, but my LEDs didn't work because most of the current was surging through the base of this two transistors, this two from the circuit, and the current didn't manage to lit up fully this LED, even like I'm putting them directly like it is, as you can see here, without a resistor. And by right now, when this is lit, the second, let me show it here. So here on pin 2, the LED, when this LED is lit up, it means this is negative actually, and this is positive, that is transmitting the signal to this transistor probably. Yeah, this wire is from pin 1 to that base of that transistor. You can see it here on the diagram if you can see it. So here is from pin 1 is going this wire to that pin 1 of this driver, ULN2003 or 5. In my case, I'm having 2003, but you can use 2005 as well. Base of the first transistor here. And the way I wired everything is a bit weird probably, but pretty much what I did a H bridge. You should look it up if you don't know what it is. H bridge with a motor between the transistors pretty much. It looks like I made a circuit drawing mistake. I drew it wrongly because here the logic is correct here. So I put the positive when it's receiving positive with this link on the base of this transistor, and the output of this transistor, the emitter, is going the 3 volts is going to the opposite of that. Yeah. All right. I made a couple of modifications. I changed this LED when the signal is a positive signal here and it's surging to the ground rail, which is, you see this line, and also as you can see the LED is very dimmed compared with when it was like this. So when this line is negative, is getting the positive from here to negative there, and is perfectly fine. The voltage is perfectly fine for the LED. It's not burning it up at all at 3 volts that I'm having it right now. So now when I'm switching it and moving it to the negative rail, you see there, and to the positive here, is getting quite dimmed because this positive signal is passing through the LED, but also is going to this gate, which is this input 7, just for testing. And I should have made this earlier, this test. So I open up my oscilloscope there, and I put this lead to the ground here, and now I'm probing this output here. It should have been inverted. It should have been 0 volts, but instead I'm getting 606 millivolts voltage maximum there. And when I'm switching to off, so now this output is showing a 0 volts here, the ground, most probably it should have. My oscilloscope is not showing anything there. But here is also not showing anything. When I'm probing that pin, is also 0, 0, 0, as you can see. So, and now I will make it high. This output is high again, and when I'm probing this testing output here, I'm getting back that 606 like that there millivolts. So it should have make it 0 volts instead of that 600 millivolts. But I believe that 600 millivolts is actually one diode from here. This specific diode that is here. So when I'm probing from here to here, I'm actually across that diode, and the oscilloscope is measuring this specific diode that is on this output here. Most probably because it's a very low value, but it should have been 0 volts. Very strange. But that's my test, and that's it. So it goes like this: when it's receiving positive signal on this pin, when this pin is positive, is becoming positive, this LED is turning off, and this LED is turning on, which is a bit vice versa, but you'll get used to it. And this is powering this gate here, which is putting this output. So this is the input, powered with positive voltage, and this output is set as negative because it is inverting. This is an inverter. When this is receiving positive, it is putting to ground here on this other side. So so the motor current is surging through this pin, through this chip to the ground, pretty much from this line. And we need here a positive that will go through the motor. But this other pin, which is powering this NOT gate here, probably either is not functioning when it's 0 volts here, either is not functioning, or it is outputting, or is putting positive voltage here. It worked with ULN2003 without this power rail. So most probably when it's not getting a signal on this, when it's getting a 0 volts signal on this pin, is not functioning. This is not opening here to the ground. So it's pretty much floating and not doing anything. Not positive, not negative, not nothing. So back to the business, when this is positive, is opening this gate and is letting the current flowing through the chip to the negative rail. But in the same time is opening the base of the transistor, which is letting this current flowing through its collector emitter, and is powering this line here with 3 volts. The maximum necessary 3 volts for this motor to be drive correctly. While this here is either positive, or already by powering here with 0 volts logic is either positive here or floating. But if I'm not dragging this wire here from this transistor, the motor will not turn by itself on. So here is not 3 volts at all from here. I did this test already, and it is not doing anything without this additional transistors on the top here to actually put power in the motor and then to surge through the chip. And the same goes for this other pin here. When this is 0, this is 3 volts or high, and it's powering this pin here, the second gate here, and in turn is creating this 0 volts rail surging. So this line here is going to the ground, and is powering the base of this transistor, which is letting the 3 volts passing this point here through the motor and then to the ground. While this point here is most probably floating and not a 3 volts inverted output. Most probably, I'm not completely sure, but pretty much I did the test and it didn't work without this stuff. So let me actually make a test. So I took out these two jumpers from this emitter jumper here, this line, and this emitter jumper here. So effectively, I'm not powering shit with these transistors. I'm opening them, but they are not letting pass anything through these lines because they are not existing. So the motor is not getting 3 volts either way. So theoretically, if this is an inverter, it should work from the inverter itself. Let's see if it's switching, and it is not switching shit. And so that's I was hoping I did this test, this elementary test in the very beginning, but now I couldn't remember it if I did it correctly with this setup what I'm having here, just to be sure. So it's not doing shit here. Let me help it if sometimes it's not doing the right thing, if I'm not bumping it a little bit. No, it's not. No, it's not even moving at all. Okay, so so this inverter, instead of putting a positive here, is actually floating. So it's between floating and negative. This is what is switching when you power the gate here. This is what is switching from the floating to negative. That's it. Either floating or either negative. All right. So I mounted back the jumpers exactly as it is in the circuit, and when I'm switching from here, it's doing back the same thing, which is correct. This is a very small H-bridge driver that I made using ULN2003 and 2 transistors because I don't have a small enough chip. I have bigger chips, but not small enough H-bridge chips to use a single chip to drive this motor. I should buy more small H-bridge chips to power, specifically to power these motors, most probably. So what I'm doing here is more as a test H-bridge, but it's working absolutely and completely okay. By the way, this ULN2003 is having 7 inputs and 7 outputs, as you can see. This is was initially built for 7-segment displays, LED displays, or even more powerful lamp displays, also 7-segment, but lamp displays. So with higher amperage, higher voltage, most probably, and that's why it's good for motor as well. But this was originally made for displays, so that's why we have 7 inputs and 7 outputs, and it can be used to drive 3 motors. The 4th motor will be this and another chip, this gate and the gate from another chip. So I will have 1, 2, 3, 6, 7. I will have 7. I can use 2 chips for 7 motors, and the 8th motor I will have to make a discrete H-bridge from transistors specifically for that one, if I will use this configuration that I'm having here without using a dedicated H-bridge chip to drive these motors. But I will think about it. It remains in plan. But unfortunately, it doesn't work directly from the output of this, as I initially was hoping. I was hoping to drive this very small motors and very easy to drive. But directly from the output of this flip-flop here, and I connected the motor like this here, but it didn't do the job correctly. So it needs a little bit of boost through this ULN2003 with these 2 transistors, or without this chip, and exclusively only from transistors. But it will be a bit more wiring to do with transistors, only with transistors. And this ULN2003 is is making life a little bit more easier, and more easier than this setup will be with a dedicated chip, H-bridge chip. Unfortunately, so to summarize, unfortunately, it didn't work directly on the outputs of this chip. I hoped it was working. If it was working, it was simplifying a ton all this test that I did here. But it's a nice, an interesting little movie. It shows that that you have to change your perspective, you have to change your direction, and to adapt with new chips that you have, with transistors, with whatever you have, to obtain the goal that you have in mind to achieve. And the goal is partially achieved with this little test that I did here. And I'm happy. It's okay. It's not smelling as burning overheated wire. It's not smelling as burning chips or heated wires jumpers here. So everything is good. And I call this experiment that I did here a success, and it's good to go. We will see if I will actually use a dedicated H-bridge. But I have so many components laying around that I should actually use them. Especially the scrapped ones that I have. And also I have a ton of new ones as well. So this project is perfect to use all my scrapped components that I have to build this driver specifically for that motor. So which actually is not a motor, is a logic element. In this case, specific case, is flipping from 1 to 0, and that's it. Is a logic 1 or logic 0, and that's all its purpose. Is not used as a motor to spin continuously. Of course, what I'm having here is just a setup just to show the driver that I built for it, and that is working. And originally, like I said already, I was curious if can be driven from these 2 pins here, from these 2 output pins that I'm having there, but it didn't. So shame on you, shame on you. And yeah, it's workable. It's workable. So next step is to actually make this element and to actually and to make this other stopping element that is retracting. A lot of mechanical stuff is next, and which is the harder part, most probably, and also the reading elements with the LED and the LDR, and we will see. Like I said before, this is just a fun idea, and is a do-it-yourself idea. It's a bit hard to make it do-it-yourself mode, like I'm doing it, but I'm showing that if you're crazy enough, like me, you can do anything at home. And I was talking with a friend from UK, from England, Great Britain, and my friend told me that actually there are chips, memory chips, and they are called magnetic RAM, MRAM, specifically to store non-volatile data, and they are very they have quite a lot of memory in them. And if I remember right, one serial chip was probably $9. One single piece, one chip was $9, and another chip which was a parallel, and also both of them were SMD components, not through hole like these ones, so very hard to actually link everything, to solder everything. That's a problem. That's one problem. And the second thing is that parallel integrated circuit, also MRAM, was having the cost of it was $27 for one single chip, which is extremely expensive, not what I was talking about in my last video, to have for $2 100 of this very extremely cheap chips, specifically for this reason, to store indefinitely, to store some variables when the power is cut. So that's an interesting news, and it's good that they exist. And also that parallel, which is way stupid expensive, it shouldn't be this expensive, but it is, it's having more memory than the serial one. And the interface being parallel is very easy to command and to program it. And that's my favorite way to go, way of communicating with a chip in parallel. It's my favorite, and it's the easiest and the most user-friendly way possible. All right, that's it for this movie. Thank you very much for watching, and I hope you like it, and see you later. Bye bye. From your favorite artist electronist, Mr. Q12. Bye bye.